Hello students, let us continue with chapter 1 real numbers. I am explaining the doubt question given by one of you. The question is, show that there is no positive integer n for which under root n minus 1 plus under root n plus 1 is rational. Before solving this sum, let us first know one property of perfect square numbers. Now the perfect square numbers are 1, 4, 9, 16, 25 and so on. Now when you see the series of the perfect square numbers, one note you can take care that the difference between any two consecutive perfect square numbers is greater than 3. Take care, the difference between any two consecutive perfect square numbers is greater than 3. As you can see, 4 minus 1 is 3, 9 minus 4 is 5, 16 minus 9 is 7, 25 minus 16 is 9 and so on. So let us proceed with the sum. Now since the sum is saying that show that there is no positive integer n for which this is rational number. We will be proving it by contradiction because most of the sums we have proved by contradiction where we have to prove there is no. So let us first suppose, if possible, that under root n minus 1 plus under root n plus 1 is a rational number. Let a by b equals to under root n minus 1 plus under root n plus 1, where a and b are positive integers and HCF of AB equals to 1. That is, a by b is in its simplest form. Let us make it equation number 1. Now, if a by b equals to this much, we can write b by a equals to 1 by under root n minus 1 plus of under root n plus 1. This can be written as 1 by under root n minus 1 plus of under root n plus 1 into under root n minus 1 minus under root n plus 1 divided by under root n minus 1 minus of under root n plus 1. Means I am rationalizing this term. So this will be equals to under root n minus 1 minus of under root n plus 1 divided by a plus b, a minus b, that is a square minus of b square. So this will be equals to n minus 1 plus minus of n plus 1 equals to over here under root n minus 1 minus of under root n plus 1 divided by n minus 1 minus of n minus of 1. So this n will be cancelled. So we are getting over here b by a equals to under root n plus 1 minus of under root n minus 1 divided by 2. This minus 2, so I have reversed the positions by cancelling this minus sign. So this implies twice of b by a equals to under root n plus 1 minus of under root n minus 1. Let's make it equation number 2. So equation 1 gives the value of a by b in terms of under root n minus 1 and under root n plus 1, and equation 2 gives the value of twice of b by a in terms of under root n plus 1 and under root n minus 1. Now we will add once equation 1 and 2 and then subtract equation 1 and 2. We will be proving that under root n minus 1 and under root n plus 1 are perfect square numbers. I mean they are rational numbers. Therefore n minus 1 and n plus 1 are perfect square numbers. We are knowing that under root of any number, suppose 4, this is equals to 2, then only we can say that this is a rational number. Under root of a not perfect square number is always equals to irrational number. Under root of perfect square number equals to rational number. I think this you are knowing. This I have done in the chapter explanation as well. So equation number 1 and 2 you remember, I am rubbing one part. This much I am rubbing. Now 1 plus 2 implies a by b plus twice of b by a equals to under root n minus 1 plus under root n plus 1 plus of under root n plus 1 minus of under root n minus 1. So these and this will be cancelled. So we are getting twice of under root n plus 1. This implies under root n plus 1 equals to a square plus of 2ab by ab, and this 2 over here. Now make it equation number 3. Now RHS is a rational number. RHS of equation 3 is a rational number. Implies LHS equals to under root n plus 1 is a rational number. Implies n plus 1 is a perfect square number. Perfect square number. Now let us subtract 1 and 2. 1 minus of 2 implies 1 was a by b and 2 was twice of b by a equals to a by b value is this much, under root n minus 1 plus of under root n plus 1, and twice b by a was this much, plus of under root n plus 1 minus of under root n minus 1. I am subtracting it, so this will become minus and this will become plus. Over here these two will be cancelled, so we are getting over here twice of under root n minus 1 equals to a square minus of 2b square by ab. This implies under root n minus 1 equals to a square minus 2b square by twice ab. Now RHS of equation 4, let's write 4 nicely. RHS of equation 4 is a rational number. Implies LHS of equation 4 equals to under root n minus 1 is a rational number. Implies n minus 1 is a perfect square number. ठीक है? Now n plus 1 minus of n minus 1 equals to n plus 1 minus n plus 1 equals to 2. Equals to 2, which is not possible. Which is not possible, as the difference between any two perfect square numbers is greater than 2. So we got our result. Hence our supposition was wrong. So there does not exist any positive integer n such that under root n minus 1 plus of under root n plus 1 is rational. Hence proved.